Okay, so let's look chemically further at what these simple versus complex carbohydrates are. Okay, so simple sugars, or sometimes called simple carbohydrates, are also called monosaccharides. Mono because they have one, what we consider sugar unit. Here's an example of 3 simple sugars. They all have the same chemical formula, C6H12O6. And as it turns out, there's over 32 isomers of simple monosaccharides that have the exact same molecular formula. And isomers, they're structural and geometric isomers. And so, for example, all 3 of these common glucose, glucose, and fructose. This is alpha glucose, this is beta glucose, and this is beta fructose. They all have the same molecular formula, but take a close look and see if you can see structurally what's different. In this case, on the number 1 carbon, this hydroxyl group is below the ring, and in this situation, this hydroxyl group is above the ring. And so that gives what we call a stereoisomer, which we did not go into in this class, but it's just the order of the groups around the carbon are different in this case. If you go around from right to left, it looks like, well, if you look at the molecule from the side, it would go OH, and then this line, and then hydrogen, and then this OH. If you go around the carbon that way. And this one, it goes hydrogen, then this side of the molecule, then hydroxide, then that side of the molecule. So just that little difference right there makes a difference in some of the chemical properties of those 2 isomers. And then fructose, the ring in fructose has 1, 2, 3, 4 carbons, but it's a 5-membered ring, whereas these are 6-membered rings. The oxygen is in one of the points of the ring. And in this case, the big difference is the 5th carbon, the 6th carbon actually excuse me. In this case, you have a carbon and a COH group above the ring, and this one a CH and an OH below the ring, where in this case you only have one of those on each of these. Okay, here we've got an extra carbon hanging off the ring. So that's the difference, and just those little structural differences make a big difference. For example, fructose, the simple sugar fructose, is about 6 times sweeter tasting than alpha glucose. Okay, so just that little structural change. All right. Another type of simple sugar is the disaccharide. The disaccharide has 2 monomer units, sugar or saccharide units, and that word sugar, saccharide, and carbohydrate are used interchangeably, you'll see. But anyway, in this case, the disaccharides, such as sucrose is common table sugar. Okay, it's been refined from either sugar beets or sugar cane, and you'll see what happens is the OH from this bound to one of the carbons and the H bound to an OH that's bound to another carbon are split off, and a new CO bond is formed between this carbon and this oxygen to give this COC linkage that links, and it's the characteristic link between the different monosaccharides to form disaccharides. And then water splits off. So this is another example of a condensation reaction that happens in nature when simple sugars are brought together to form sugar linkages. And you can imagine this reaction is in reverse, is part of metabolism, where sugars are broken down, and that when a sugar is broken down, water is added to the disaccharide to break it into the individual sugar units. Okay.